Welcome to the Kontinuum lab. This here is my newest instrument. I call it the virus pad. This is a Kontrol Freak project, and that basically means two things. First of all, I used some weird materials to make it. For example, these storage boxes here, which form the basic structure. And second, of course, I filmed the whole process, and this is the video where I show you how I made it. So this is a long one, so get yourself a cup of coffee and a soldering iron, and let's get started. So apart from these boxes, of course, I'm going to use a bunch of other materials. So let's have a look at that. As usual, I've gathered everything together in this little box here. So first of all, here's the velostat material, which forms the heart of the sensor. And then we have some of the same kind of supplies that we used in the last video to make the voltage divider. Then we have this multiplexer here because I'm planning on using quite a lot of sensors. Specifically, I'm going to use all the channels here and make 16 sensors. Here we have the whole sensor setup from last time. I will definitely be using this microcontroller, but I won't be using this little voltage divider here because now I need to replicate this 16 times over for today's setup. And then I have this bunch of cables here to connect everything together. I included these two potentiometer modules from my Kontinuum lab instrument kit. And then of course I have some of the structural elements for the sensor setup, double-sided tape, the copper tape that I use for electrodes, and then this foam tape here, which is this black foam tape, which I think I'm going to try to use as a button surface because it's nice and squishy, but pretty firm. And so let's see how that works out. I forgot something. I have a sheet of plastic that I'm going to use for the surface of the sensor. Let me just get that. This is a sheet of PETG. This is 0.5 millimeter thick. I think that should do nicely. I'll try it out and see how it goes. So the way I see it, there are three pieces to this puzzle. We need the basic structure, which consists of these two boxes here and the base that I still have to make. Then we have the sensor itself with its layers and its different kinds of tape and stuff. And then we have the electronics, which go inside and which make all of the sensors work. So I'm going to start with the basic structure, and then I'm going to put together the electronics, and then finally I'll put together the layered sandwich of the sensor. Let's get started. So like I said, I need to make a base. I have an idea for that, and of course it involves corrugated cardboard. First of all, I need a base piece big enough for both of them. Cool. Now for strength and stiffness, I'm going to make a copy of this but turned 90 degrees so that I get stiffness in the other direction. Use the first one as a template. Now in order to hold the boxes in place on top of here, I'm actually just going to make like a layered tower of maybe 3 pieces of this cardboard, exactly the size and shape of the inside of the box, and then I can just push it down over it. So let's do that. I think that's cool. Let's see what that looks like. So 3 layers of this. I think that should be enough. I also want to make sure that there's still room for the breakout board inside. Okay, let's get started. First I'm going to just glue the 2 base pieces together. Nice. Really want to get the edges here. Give it a couple of seconds there to set. Let's see. Really? Just like that? So what if I peel it off now? Let's see what happens. Yeah, hells yeah. That's nice. It's really stuck on there. Sweet. Cool, let's put the other one on there. Nice. Good, so let's talk about the instrument itself. As you saw in the beginning of the video, there's supposed to be 16 pads on here, 8 on each box. Each sensor is going to need a voltage divider circuit in order to function. That was this little board here, which as you can see, it has 2 pins at one end going off to the sensor, and then it has 3 pins at the other end, which are ground, 3 volts, and signal. And they go off to the microcontroller. So this is the next step. Let's get started. I was actually thinking of doing 16 voltage dividers and doing a whole little circuit board here, but I just realized that I'm going to be reading this through the multiplexer and it's 16 channels. So I think that I can just take the signal pin off here and do a single voltage divider after that between the multiplexer and the microcontroller. I really hope that's how it works, because that just makes this much easier, and I'm honestly not really sure. I mean, I'm not an electrical engineer, so I'm just going to try it out and see if it works. So the first test that I want to run here is just a single sensor through the multiplexer. I'll use the sensor from the previous video and the multiplexer is right here. So let's just test that. So I just get the signal pin from the multiplexer and I plug it into the central rail on this little voltage divider circuit here. So this is the rail that has a resistor off to ground, right? So we can still just connect the other side of the voltage divider into the analog section here on the microcontroller pin 25. So let me just connect the rest of these pins to the microcontroller. Now to connect the sensor. So we need to connect this with 3 volts on one side and the signal on the other side. And then of course the sensor needs to go into the multiplexer. I'm putting it on pin 0. Time to plug back into the computer and see what we get. So here we are in Arduino. I put together this little sketch here which defines the multiplexer, and then in the main loop here I just run this function which sets the multiplexer and then reads the multiplexer value. So let's upload that. Okay, that looks good. Let's open the serial monitor. Okay, that looks pretty promising. So yeah, that's definitely working. I'm pretty sure that means that I will be able to read all of the 16 sensors through the same little voltage divider and end up with a much simpler circuit. So, okay, let's get rid of this whole test circuit here and then start setting up the final electronics. So I've decided that I'm going to stay as close as possible to the test setup by actually using the same voltage divider circuit. So if we go in there, the red one here is now the ground cable. So on this click breakout board, there's a little 3 volt rail and a ground rail down here, so we can just plug that in like that. And then this one will go straight over here to the signal pin on the second multiplexer. And then of course the multiplexer will plug in here as well. There. And then the signal coming off the multiplexer will be the input for the voltage divider, there. And then this empty pin here is the 3 volt pin. I might use that. I need a common 3 volt rail for all of the sensors. So now I just need 16 cables that I can plug into here and then solder to the copper electrodes that I will make out of this copper tape here. So just a second. Yes, I knew that I still had some of these lying around. These are just female header cables, but with one end stripped. So as you can see, I have a selection here of shorter cables and somewhat longer cables, because I need to connect 8 sensors in one box and the other 8 sensors in the other box. And at the same time, the electronics will live inside one of the boxes. So 8 of the cables won't need to be very long. Okay, first of all, let me just try to stick this inside here and see if any of this makes any sense. So maybe I shouldn't have the breakout board and the multiplexer in the same box. Maybe what I need to do is first run the multiplexer in from one box to the other, and then run the cables back that need to go back, so that I will spread the bigger components out between the two boxes. So I'm a little worried about cutting into the edge here, because I think that might mess up the whole integrity of my closing solution here. So instead I'm going to run the cables through the bottom here. So I'll make a hole downwards, and then I'll take out a bit of the bottom layer here, and then I'll make a hole on the other side where I can run the cables up through. Okay, so we got our little channel here. Okay, so losing light, yeah, definitely losing light. So just as I was explaining that, my camera ran out of juice. Cables will run through here, and then when I'm done with the whole thing, I'll probably put on another layer just to cover that whole thing up. The multiplexer will go over here on the other side. Cables will be folded up, probably a rubber band on there maybe or something. Okay, so I ran out of battery. I only have one more battery. Okay, so just as I was explaining that, my camera cut out again because the card was full. So let's just close this up and see if that's even possible. Yes, that's possible. Yes, just like that. Okay, so I'll stop there for today. Of course, in the video, I'll just make a quick edit and be right back with you. I am back, and looking at this now, I'm super happy with the result so far. So let's get to it. Over here is the rest of the stuff that we need. And I'm about to start on the top surface here where the buttons will go. So first, let's sketch it out. I need 8 buttons over here and 8 over here. So that will be the distribution of the keys on here. And that's the space that we have for each set of components for each button. I'll need to make some holes in the boxes to pull some cables through, but instead of using the top surface for that, I will do that below the edge here on the side. Cool, that plastic actually drills really nicely. This next part is kind of tricky because in order to get all the cables inside, I need to first have the copper strips already on there, so I have something to solder the cables to. But in order to do that, I have to first put on the double-sided tape. So that's exactly how it needs to be. There, I'm leaving a little bit of an edge uncovered. Before I peel off the backing material here, I'm going to cut out my electrodes. $16 of those. Now I need 4 long pieces. And fold my way to that. Fold again. But now I'm ready to start sticking down these guys. So this is a point of no return. I'm peeling off the backing paper. Nice. So now the next step is to get the cables in here, through the holes, soldered to the pads. First I'll just get a little bit of solder on each pad. I'm going to number these before I move on. Okay, that was silly. I'm going to cover that up in a second, so I need to write these numbers on the inside. So as you can see, I put the long cables in here. That's because this is going to be the one where the Teensy microcontroller is. So that means that the other box will have the short cables. Okay, all the connections are made. Actually, what I really want to do right now is use a little bit of hot glue to stabilize these cables so that they don't wiggle around and end up breaking the solder. The next step is to put on the velostat material. So I'm cutting out individual pieces for each electrode that is only slightly larger than the electrode surface. Nice. So let me do 15 more of those. So that's both of them all done. As you can see, there's still plenty of adhesive surface left so that I can stick the plastic layer on top. I might as well just stick this on there right now because that will allow me to solder the cable to it. So now I'll stabilize under here with a bit of hot glue. So now I'm going to peel back the backing on the copper tape. So now all that's left to do here on the outside is the plastic cover, and that's pretty simple. So I was having a look at this material here and I'm not sure it's the best for this. I think it might be too thick. This lid here I think is a bit thinner and a little bit softer. I think it'll work quite a lot better. .3, and this here I already know is 0.5 or so, 0.6 and a bit with the protective cover. So this goes out. I'm sticking with this stuff here. That's one piece. Cool. Okay, so now this is a little bit nerve-wracking because there's no undo on this. So I'm just gonna go for it. There. Right there. Okay, so before I get to plugging in all of these cables and putting the boxes back on here, I still have two potentiometers that I want to insert. So this is pretty simple. I'm going to stick them here, one at the end of each box. Here they are. There was a little bit of cracking going on there, but I think we'll be okay. That's what that looks like. Nice. I managed to do that second one with zero cracking. Excellent. So now I need to make a hole for the little tab that holds the potentiometer in place. And the other one. Okay. Let's see if that works. Perfect. Check that out. And now I can insert the little washer and then the nut. You can get the knob on there. There. Very nice. Let's put the other one in. Cool. Knob on there as well. That's looking very cool. So there's two more things that I need to do before I plug in the cables. The first one is that I want to include an external button here that I can use as a calibration button, which would be practical if I need to recalibrate the sensors for some reason. So here is one of my little button modules. A good place for it would be right on that shelf there. I like that. So I'm making a hole right here for the button cable to pass through. Sweet. That's just big enough. And put a little extra glue in there to stabilize the cable as well. So now there's just one last thing to do before I start plugging in the cables. And that is, of course, to add some buttons to the top of this. And by buttons, I just mean a nice tactile surface. in the form of this foam sticky tape. Nice. That's what it looks like. Yeah. And the last one. Excellent. So that's all of the sensors finished, all of the cables inserted, and now it's time to start plugging them in over here. Good, so now all of those cables are through, and if you remember here, all of the sensors are numbered, and these are the numbers that I'm going to use as I plug these sensors into the multiplexer. The rest of the cables from this box here all plug in directly to the breakout board, so let's leave those for now. Then we have the 8 sensors over here. They have shorter cables because they plug in within the same space. And so now I can plug in the cables from the 3-volt rails. I'll start with these two, which I need to pass through the hole in the base. And come to think of it, I also need to pass the potentiometer cable through, so I'll just do that right away. I'll put this on pin 20, and then I can put the other potentiometer down here on pin 21. Then I can grab these two cables here and plug them into the 3-volt rail over here. And I have another 2 cables here that I need to plug into 3 volts. So now the calibration button, I think, is the last thing I need to plug in. The breakout board has a spot for a calibration button. Specifically, it says cal right here behind the microcontroller. So I'm just going to plug right in there. Wow, so now everything's plugged in. And I'm basically ready to close this up. It's looking pretty sweet. However, I just remembered one thing here. I need to pull a USB cable through somehow. Let's see. The first thing I'm going to do is I'm going to glue the microcontroller in place. I'm just going to close this one up right now, and then I'm going to just temporarily close this up to see where I need to make the hole. So that's where the hole for the USB goes. I'm going to try to cut this hole out while everything is assembled. Okay, there's a hole there. So let's see if it's actually possible to plug it in through here. What do you know, it's plugged in. Nice. Seeing as everything's plugged in and pretty much ready to go, I guess it's time to plug into the computer and upload some code on here and see if we can make it work. Let's do it. So, it's now the next day, or has it been 2 days? I'm not sure. Everything's a blur. Anyway, I'm back and I have everything up and running. There are 3 new things that I want to talk to you about. Let's see. First of all, the calibration button that used to be here is now a 2-position switch. I'll tell you why in a second. The second new thing is that I thought of a name for this instrument, and I've decided to name it in honor of the crazy situation that we're all living through right now, the virus pad. The third new thing, of course, is that I wrote the actual code to make this thing work, and that turned out to be a little bit trickier than I had thought, but that's what we're about to have a look at right now. So as usual, I've saved a few snapshots during development, and this is the first one. This is a pretty simple sketch which just reads all of the sensors through the multiplexer and then prints the results out to serial. This is the sketch that's on the board right now, so let's just try and open the serial monitor. Okay, so it looks like that's working quite well. So here we have the 16 main sensors, and then down here we have the 2 potentiometers. Let's see what we can get. This one here should be the first sensor. And it's working great. We're getting like 400 points of resolution or 300 points or something like that. Let me just run through the sensors and try them all. Nice. Cool. Sweet. Yeah. Yeah, that's really nice. They all have high resolution and seem to work really well. As for the potentiometers, they also seem to be working really well. 1 to 1023, which is exactly what you would expect. So that's pretty sweet. Let's have a look at the second sketch. So the second sketch includes all of the code that was there before, but now it gets a little bit more complex. I've hard-coded a threshold value for each sensor in here, and then I keep track of which sensors are currently over the threshold. I've also included these two functions here, which serve as an exponential filter and help me smooth out the readings from the sensors. But the biggest change is here in the main loop, where I now constantly keep track of the previous sensor readings and then compare them to the new sensor readings in this difference value. So the reason why I even need this difference value is because these sensors have a tendency to drift quite a lot. And so to combat that, I need to keep track of both the specific reading from the sensor, but also the speed with which it is changing readings. And that's where the difference value comes in. In order for this instrument to register a key strike and output a note, the sensor reading has to be over the sensor reading threshold, but the difference also has to be over the difference threshold, which is this value here. There's still no MIDI code in this sketch, but if we register a keystroke, then we will get this serial output here and a 1 second delay. So let's try and upload that. Excellent, let's open the serial monitor. As you can see, it's still the same output, just without the potentiometer readings. But as you can see, when we hit a note, it pauses after writing out the value of that sensor and then writes out the note value that it would output. So that works really well. Let's move on to the third sketch. So here's the third sketch, and again this one adds quite a bit of complexity. The first thing here is that we're now also keeping track of a maximum reading value for each sensor because we need to do some mapping. And then you can see that the calibration button is now called a mode button, and that's because I've introduced two different playing modes. So one mode is the original one that we saw in the last sketch, and that will output a percussion-like signal with a velocity value. The second mode is going to be like a keyboard kind of function where you can control the volume by pressing harder or softer. So let's have a quick look at those. As you can see, we now determine the playing mode based on the position of the mode button, which is not a button, it is now this switch here. And now if the playing mode is 0, we then run through this little loop here where we do the same as before, calculate the difference value, but then we also turn the difference value into a velocity, and then we output the MIDI note with that velocity. Or else, that means if the playing mode is 1, then we do this loop here, which now that I look at it actually does exactly the same thing, at least in this code here, except that it has a note on and a note off message. So it keeps track of you holding your finger on the key. There's no volume control for now. Let's try and upload that. So we can open the serial monitor, but that's a little bit boring because it's actually just the same output as before, except that now it doesn't have the 1 second delay. So to really be able to tell if everything is working, we actually need to open up the software synthesizer and see if we can make some noise. Let's do it. So here's Yoshimi. Let's connect that to the MIDI controller. There. The two different modes here are outputting to channel 1 and channel 2 respectively. The percussion one should be on channel 1. So let's open up a drum kit there. That should be fine. And then on channel 2, we will pick one of my open horn instruments, like this one. And that's it. I'm not even sure what mode we're in right now because I don't know the position of this switch yet, so we'll see. Okay, that was definitely percussion mode because there's no note off. Okay, we're working. So we're working. The sensitivity of each key is a little bit off. Like this one has a really loud velocity and this one really doesn't. But it works. There's no volume control yet. So there's that. It also works polyphonically, of course. Okay, let's hit the switch and see how the percussion mode works. Yeah. Let me just turn up the volume here a little bit. Okay. Hopefully you can hear that. I'm lifting it up off the table because the microphone is kind of on the table, so I don't want the sound to transfer that way. Everything worked great, although of course the bass drums and such are not making a lot of noise through my laptop speakers. But yeah, that's nice. Let's move on to the fourth and final sketch. The fourth sketch adds a couple of details, although most of the functionality was already in place. We now have two new arrays here, one with some note values that we output. As you can see here, the first 4 of them have a different progression than the rest. The same thing happens in this array, where we define MIDI channels. The first 4 go to channel 16 and the rest of them go to channel 2. This is directly reflected in the instrument in that the first 4 are these 4 buttons here, which are now going to be designated to looper control. The rest of the keys, these other 12 here, still have the same functionality as before. So let's have a look at that. Playing mode 0 is almost exactly the same as before, but now we are only counting from sensor 4 to sensor 16, not from sensor 0 and up. For playing mode 1, which is the keyboard-like setup, we do the same thing. We only read from sensor number 4 and up. And then we start, just like we did before, calculating the velocity from a difference value. But then there's this new trick here where I keep track of all of the active sensors, meaning the keys that are currently pressed down, and which one was the last one to be pressed down. And so I'm constantly reading the values off of that sensor, mapping that to MIDI values, and then outputting that as a volume value. In my case, I'm using continuous controller number 2, which is generally for wind controllers. It works really nicely with Yoshimi, so that's what I'm using. Then, of course, I reintroduce the potentiometers, read those, and map them to MIDI values, and then I output a continuous controller for each of them on CC111 and CC112. And that's it. Let's try and upload that. Sweet, that seems to work just fine. Let's reconnect the synthesizer. Let's switch back into keyboard mode and see if the volume control works. Let's pick another instrument as well. So first let's try a single sensor. That's very cool. Let's try a couple of sensors together. Oh yeah, and of course, these buttons aren't doing anything right now because they're being sent off to channel 16 and I currently have no instruments in channel 16, so we'll deal with that in a second. That's very cool, so I'm quite happy with that. Let me try to hit the switch here and go back to percussion mode. See how that works. That works exactly the same as before, except of course that these 4 here don't work anymore. So let's make them work. Let's open up the looper and see what we can do. And here's Super Looper. Load up the MIDI input values. I keep mine here. And then we need to connect the MIDI controller to Super Looper, and we need to connect the synthesizer to Super Looper and then output Super Looper to the speakers. Excellent. So let's see a quick first test. Yeah, that works. So this over here should be the overdub control. Yeah. Oh, damn it, I was just about to say goodbye and I almost forgot the potentiometers. This is pretty simple, they just output a continuous controller. So Yoshimi can MIDI learn those continuous controllers. I just control right click on this knob here and then I move the controller. There you go, that's one of them. And then I control right click on the other one here and then I move that controller. So now these 2 knobs here control, as you can see, the system effect sense. So we just need to put an effect on there. 0 echo. Turn the echo up. And then on the second one we can put a distortion value. No distortion. So there you go. Now the 2 knobs here are mapped to echo and distortion, but it could be any other kind of effect combination. Okay, so everything works. I have to say this instrument was pretty tricky to put together. These sensors are much harder to make than my capacitive sensor-based keys, and the code was hard to put together because these sensors drift a lot and they're a little bit unstable. But I made it work and now it's fully functional. I am going to spend a few more hours with this and try to make some nice music, and I'll put that at the end of the video, which is basically right now. So cue the music. So this turned out to be a pretty long Kontrol Freak video. mostly because of all the complications, but also because, of course, I'm not in a hurry to go anywhere right now anyway. So I hope you enjoyed that longer format. If you did like the video, then please consider subscribing to the channel. And that's it for today. Take care until next time, and I'll see you in the Kontinuum.